Chapter 3. AI Testing Prologue. This research aims to selectively predict testing samples with high confidence using past data. Driven by the limitations of artificial intelligence, AI. AI inductive reasoning is bounded by pre-learned labels. Consequently, when AI encounters a sample with an undefined label, it selects the best matched label from the pre-learned set and leads to inaccurate recognition. To address this limitation, I propose leveraging metacognition AI, which validates AI identifications based on the confidence assessment of a meta-AI. In pursuit of this AI recognition design, this test study aims to 1. Determine which labels, grandparent or child level, have a higher number of test samples with over 95% prediction confidence. 2. Evaluate the prediction accuracy for these samples. Chapter 3:1. Grandparent versus child level labels. In this experiment, as depicted in this figure, both AI Model A and B are trained using identical datasets with grandparent and child level labels. Upon completion of training, the same testing datasets are applied to both models A and B, as illustrated in this figure. The evaluation process centers on two main aspects. 1. Determining which model attains a greater number of samples surpassing the 95% confidence threshold. 2. Evaluating which model achieves higher accuracy for samples exceeding the 95% confidence threshold. Chapter 3:1. Best test case grandparent level labels. The best performing case is Model A2, trained on training dataset 2 with 8 grandparent level labels, as shown in this figure. Model A2 selectively collected approximately 70 to 80% of all testing samples, exhibiting over 90% accuracy. This represents an improvement of about 10% p compared to the accuracy achieved without sample selection. Chapter 3:1. Test conditions. In this evaluation, as indicated in this figure and tables, models A and B underwent training using 3 datasets incorporating grandparent and child level labels. Consequently, each of the 3 models A and B is evaluated for a single testing dataset, amounting to 6 models in total. Chapter 3:1. Test Dataset 1, Test Results. In summary, Model A, Grandparent Level AI, outperforms Model B, Child Level AI. Model A selectively collects a larger portion of samples, 80%, compared to Model B, 20%, as indicated in this figure. However, there's a slight difference in the prediction accuracy for the selected samples, with Model A achieving 93.6%, slightly lower than Model B, 93.8%. Chapter 3:1. Test Dataset 2, Test Results. In summary, Model A, Grandparent Level AI, outperforms Model B, Child Level AI. Model A selectively collects more samples, 70 to 75%, from testing dataset 2 compared to Model B, 10 to 20%. Additionally, Model A achieves higher accuracies for these selected samples, 90.3% and 91.9%, compared to Model B, 91.1% and 84.4%. Chapter 3:1. Conclusions. 1. Grandparent level AI selective collects 70 to 80% of the testing datasets. 2. ground parent level AI predict correctly over 90% for the selected samples. 3. Training dataset 2 is better performance than training dataset 1 and 3. Therefore, my AI recognition design starts with AI trained using 1. Ground parent level labels, 2. Samples from training dataset 2. Thank you.